All right. So we're going to do a little bit more review or possibly some introduction depending on your experience. What do you think? You think you recognize any of these words?
Yeah, I've used those words before.
Yeah, a lot of us have used these words, but let's see if we really kind of understand them and make sure that when we communicate with these words, we know what we're talking about. So the term atom. We talked a little bit about this already, but our model of the atom, to get started at least, should be a nucleus with neutrons and protons with our electrons all over. It's the smallest particle that exists in nature in terms of from a chemical perspective. We're learning all the time, and we can get much smaller particles out there nowadays. But for chemistry, this is the smallest unit of matter. All right. And now there are different kinds of atoms. There's a lot of different kinds of atoms. We'll introduce that in a bit. But everything is made up of these atoms. Okay. A molecule is a combination of atoms. Specifically, a molecule is a combination of what we call nonmetals. Okay. Now, to understand nonmetals, we have to bring out a periodic table. Have you seen a periodic table before?
Yeah.
Okay, very good. So this periodic table has a green staircase here that separates the metals from the nonmetals. So you can see a molecule. You can tell a compound is a molecule because it will only contain these nonmetals in it. Hydrogen, however, is an exception. It's an exception, and it's also a nonmetal. So it's an exception in that it doesn't cleanly look like it's to the right of this staircase. The staircase bends over like that, right? So hydrogen's included.
That's silly.
Well, it's just an exception then, if you want to be serious about it. Okay, so a molecule is a compound that's made up of nonmetals, all right? It's a combination of these atoms, of different atoms, right? They can be small, but they can also be very large. Like a DNA, DNA is considered a molecule. It's a biomolecule. Proteins are considered biomolecules. They're very large, but in this class, we're generally going to be dealing with small molecules, okay? Now, an element is what we call any kind of set of atoms that are all the same. So, for example, if I have atoms of carbon, a pile of atoms of carbon, I can say that that is elemental. That material is elemental, right? Or if I have a pile of gold, I could say that that is one element. It's all the same element. If I have a pile of sulfur, it's all sulfur. It's all the same element. These are all the different Legos or different atoms that I can use to make up a compound, okay? Or to a compound or a molecule, or bring elements together to make something new. Now, we see on here some information. So this says boron, for example, and this 5 there. That 5 is telling me something. Do you know what it's telling me?
Yeah, I remember from class before.
Okay, what is it telling us?
It's telling us the number of mass.
Well, not quite the number of mass. It's the number of...
Oh, the number of protons.
That's right, the number of protons. And neutrons are also in an atom, so they contribute to the mass as well. But this number up here tells us the number of protons in that kind of atom. So if I have sulfur atoms, each sulfur atom has how many protons?
16.
That's right. If I have nickel atoms, each nickel atom has how many protons?
28.
Very good. That's also the number of electrons that they'll have in general, starting off with, if they don't have a charge, all right? So if you see something that says, for example, lithium, you can use your periodic table to see how many protons and how many electrons an atom of lithium has. Very good. So we have these chemical symbols, these letters on the periodic table, and generally they're kind of the first couple letters, depending on if there's multiple elements with that same, starting with that same letter, right? So we don't want to spend a whole lot of time memorizing the periodic table. I wouldn't do that if I were you. I think that the best thing to do would be to use the periodic table a lot, get used to it, look at it a lot. Don't be guessing. Just look up the letter and become more familiar with it that way. All right. We have chemical equations. So the chemical equation for water is H2O. Chemical formula for water is H2O. Chemical formula for carbon dioxide, CO2. And we'll talk more about these chemical formulas in the future. But in general, we see that the 2 down here is telling me that I have 2 what?
Hydrogens?
That's right. Because it's after the hydrogen, I have 2 hydrogens. We don't put a 1 down there if I only have one of the elements. So that means I have 1 oxygen there. All right. So water, carbon dioxide. Those are some chemicals that people are familiar with. And most are based on English names. However, some elemental names are based on older languages, languages that used to be more scientifically minded a while back. So you get some letters that don't begin, some elements that don't begin with the letters of their English name. So don't be terribly concerned about that. Just look up the elements when you need to. Now, another term, a couple of terms here that we want to know. A compound, and you heard me use the word compound because a compound is a combination of elements to form a new substance with different properties. And that's what happens when you bring elements together and a new compound is formed. Then you have a substance with new properties. Okay? So I'm going to introduce to you kind of a diagram here that would help us kind of think about what we've learned, what we talked about so far. So if we had all of our compounds, all right, circled in this region here, all of our compounds. So far, we've talked about one kind of compound, and that's been molecular compounds. Molecular compounds, they are molecules, and I've told you up front that we can kind of identify molecular compounds because they're made of non-metals, all right? And I'm also going to introduce to you now our second kind of compound. It is called an ionic compound, and we'll talk more about that in later chapters. But in general, right now, it'll be easy for us to identify an ionic compound because it will contain a metal. Contain a metal. Now, do you remember how we can tell whether an element is a metal or a non-metal?
Yeah, you said that the staircase separates them.
That's right. This green staircase here will separate the metals from the non-metals. Which side is the non-metals?
Let's see. Well, I see iron down there. So that side must be the metals.
Okay, good. So here we have our staircase. Over here are our metals. And to the right are our non-metals. Very good.
And don't forget hydrogen.
Oh, yeah, that's right. Hydrogen is what?
A non-metal.
Very good. That's our exception that we want to always be aware of. Very good. Okay, so our chemical formulas like H2O, FePO4, NaCl, H2SO4, we need to be able to know how many elements, how many of the different kinds of elements are in these chemical formulas. So we need to be able to see, for example, in H2SO4, I have some hydrogens, I have some sulfurs, and I have some oxygens, and I need to be able to know how many of each. Okay? Can you tell there how many hydrogens, sulfurs, and oxygens?
2 hydrogens, 1 sulfur, 4 oxygen.
Okay, very good. Some elements out there, like hydrogen, oxygen, nitrogen, fluorine, chlorine, iodine, and bromine, some elements out there, when they are elemental, they actually go around in pairs of atoms, like hydrogen gas, H2, oxygen gas, O2, okay? So for a lot of elements, when you just write the element by itself, you would just write the elemental symbol, but for some, they are what we call diatomic. Diatomic, they go around in pairs like this, okay? And this isn't something terribly critical to start off with. You'll gradually kind of understand it, but when you see an element that is diatomic, don't be afraid of it. Recognize that if it's O2, for example, that means there's 2 atoms of oxygen, and that's because in nature, that's how you find that element. Chemical formulas sometimes will be written in different ways, and that's just to kind of sometimes written one way to help us understand what the structure looks like. So don't be afraid of elements written different ways. Sometimes, though, it could be a completely different compound, so you do have to pay attention to that. Sometimes you have to ask the person, what is the structure of this compound? Simply from looking at the chemical formula, you can't always tell what it is. But that's mostly in a different class. In this class, the chemical formulas will generally tell us exactly what the compound looks like, okay? All right, very good. And so then we also have what we call hydrates. Hydrates are compounds that absorb water. And this becomes a problem a little bit if you're working in the lab and you want to get a certain amount of your chemical into a reaction, for example. If I have, let's use this example here, copper sulfate, all right? If I have this example, CuSO4 is called copper sulfate. If I have a bottle, a container of copper sulfate, here it is, my container. I have the lid. I keep the lid on tight because if I take the lid off, then the copper sulfate inside, the water from the air will come and kind of stick to the surface. And then the next time I weigh out my copper sulfate, some of what I weigh out will be water. And that's not good, right?
No, because then you're not weighing out copper sulfate, you're weighing out some water too.
That's right. And I'll think I'm weighing out copper sulfate. So you get a differing amount of water each time if the material is very what we call hygroscopic.
What does hygroscopic mean?
It means it absorbs water from the surroundings, okay? So, I don't know if you've ever seen little packets of drying agent in shoes or in certain kinds of food like beans or dry foods. They absorb water because if there's no water, then it's hard for bacteria to grow, and that helps with smell and freshness of food, right? So this is a property that we've taken advantage of for a variety of different ways. But sometimes chemicals will come as hydrates so that they won't pick up more water, okay? And so then every time you weigh it out, you know what you're weighing out. Even though it has a hydrate on it, that's okay. You can just compensate for the mass that you need with that hydrate. So, very good. We've come to a point now where we should be able to know the answers to these questions. I'm going to let you guys work on each one, and then we're going to work on it together. Does that sound okay, Fred?
Yeah, that's okay.
All right, so push pause, take time to work on each one of these before we give you the answers. All right, we're going to give you the answers now for the first one. What do you think, Fred? How many sodium atoms in the first one?
2.
Good. How many carbon?
1.
Oxygen?
3.
Excellent job. Okay, here comes the second one. Let's work on the second one. Before you look at the answers, make sure you work on it. Okay, what do you think, Fred? How many nitrogens?
1.
1? Why do you think that?
Oh, I see 1 nitrogen there.
Okay, so what does this parentheses mean?
I don't know. That was kind of throwing me off.
All right, so what that's saying is this group, NH4, that group, there's 2 of them.
2 of those NH4s?
That's right. So if I have 2 of these clusters here, then how many nitrogens must I have?
Must have 2.
Very good. And hydrogens?
4 times the 2?
That's right. Or what?
8.
Very good. Now, how about sulfur?
4.
No, that 4 here is only for that oxygen, right?
Okay, so just 1?
That's right. And oxygen?
4.
Very good. So 2, 8, 1, and 4. All right, take a stab at the next one. Let's see what we got. All right, did you get to take a chance? Make sure you take your chance. Try. That's the learning. If you just zoom right through, you're not going to get the learning. So, how many magnesiums, Fred?
3.
How many phosphoruses?
2.
Oxygens?
8.
Very good. Excellent. All right, try this one. What do you think, Fred?
I don't know what that 5H2O thing means.
Well, do you remember what kind of a compound this is if it has water with it?
Is that the hydrate thing?
Yeah, hydrates. That's right. So this is called copper sulfate, and the way we name it is copper sulfate. We have a prefix for 5, which is penta, and then we say hydrate, because this is just hydrated copper sulfate. So these water molecules are kind of surrounding this material. They're not changing the chemistry or changing the interactions here of the copper and the sulfate. Okay? So, in this statement here, I have 1 copper, 1 sulfur, 4 oxygens here, but then I have 5 H2Os, so that means 10 hydrogens and 5 additional oxygens. So there's just going to be 1 copper, there's going to be 1 sulfur, and then there's going to be 4 plus the 9 oxygen and the 10 hydrogen. Okay, did you get that?
I think I got it.
Very good. All right, good work today.